I'd like you at your tables to model these 3 addition problems.
420.
Sorry. No, that's 155.
Let me give you one more addition to do.
6, 7, 8.
Imagine you're doing this on paper. Someone talk me through what I write down and where, and what you say as you do this problem. Robert, you were saying?
Carry the 1.
So, carry. Carry the 1. Are we carrying the 1?
No, but it's going to
the 10th.
look like it looks on the paper.
So putting a 1 in this column means that 1 represents what?
10.
10. Okay? So this doesn't represent 2, it represents 2 lots of 10s. 3 lots of 10s. So when you say carry 1, what are you actually doing? Yeah, we're actually moving.
In Chinese, we put a dot at the bottom of the 3. We put a dot, not a 1. Yeah, here, yeah. You put a dot? Yeah. This is what we do. So if it's over 10, and then we put a dot, yeah, in the 10, yeah, over there.
Well, these are the kinds of things that we need to pay really close attention to. Because, you know, if I saw a student doing that, I wouldn't really know what they were doing. Nothing wrong with that. But what we want to do is to teach our students that, okay, that's interesting, that's how you guys do it. In Australia, we do it this way. And the importance of saying in Australia we do it this way is not because it's better or it's more correct, but if we have adult learners who have come to your numeracy class because they want to help their kids with their school numeracy, then it's helpful for the adults to know what is taught in Australian schools. It's important to find out how the student has learned it, how the student does addition or subtraction or whatever, but also to make them aware of how we do it in Australia. And also, I think it's really interesting to share how all the other students have learned it in their own culture. Really, what you're doing is breaking down the number. So, you know, we get 5 and 8 make 13, and we're really saying, okay, so that's 1 lot of 10, 3 lots of 1s, and the 10s don't belong in this column. We need to put it in the 10s column. All 10s go in the middle column. The largest number that we can put in the 1s column is 9, right? As soon as you hit 10, you've got to move up or move to the left. It's the value attached to each place, each position. Each column has a value. And if you don't recognize that, then none of this makes sense, because the rules are built around this place value system. You know, we often are taught that mathematics is the one universal language, or that mathematics is culture and value-free, that it's neutral. But when we look at just quite simple things like, how you do subtraction or how you do addition or division, you find out that, people from different educational backgrounds, from different countries, have learned to do these simple arithmetic operations very differently. What about subtraction? What I'd like you to do before you play with the base 10 blocks is to show each other on paper how you learn to do this subtraction and the language that you learned to go with this kind of subtraction.
So I'd cross that out, make it a 3, make that 15.
So why did you make a 4, 3?
Because I need to take from somewhere and I can't take from nothing, so I need to take from the next one across. Yeah.
One dot above each.
Borrow one.
Just one dot.
I was wondering if it was two dots to make one.
Like the tens and you thought like two
Only one dot.
above the hundreds. You're doing the English. Yeah.
The English.
I saw 3 different methods on this table. So I might get Tim to just walk and talk me through what you do and say and write. So
5 minus 9 we can't do. So
5 minus 9? Yeah, 5 minus
Yeah.
9
we can't do that.
Okay,
So add,
hang on a second.
I'm going to become very conscious of my
9.
language now.
Can't do.
So add 1 to the 5, make it 15.
Usually when I add 1 to 5, I get 6, but never mind,
There we go.
right?
Good enough. All right, so 15 minus 9 equals 6.
15. Yep.
Good. Okay, now we have to pay back the 1.
And how do
Okay.
I pay back the 1?
So change the 1, change that 19, change that 1 into a 2.
Like that?
Yeah. Now 4 minus 2 is 2.
Subtraction. There's a generation of adults in Australia and I think in Britain as well who've learned the method like they were learning a nursery rhyme. 9 from 4 can't do, borrow 1. 9 from 14 is 5, and they write 5, and then they say pay back 1. 1 from 2 is 1 or whatever. So this borrow and pay back is really very strongly ingrained in their mind as what you have to do when you're subtracting a bigger number from a smaller number. So I started asking the students about this paying back business. And it completely threw them. None of them could explain to me what was going on. As it turns out, it's got nothing to do with borrowing or paying back at all. It's just, I guess, a useful way to teach children a method because, it's hammered into them that if you borrow something from someone, you always have to give it back. So it's, this learning subtraction is tangled up with some moral lesson. And it stuck with them. But when you were first taught this method, did you ask the teacher who we're borrowing from?
Probably not.
Why
I don't
not?
think it was a very collaborative classroom.
You didn't ask questions. You did
No,
what you were
just
told.
did what you were told.
Well, I just want you to look at something. So do you see the blue bar and the black bar? Which is the longer, the blue? Would you agree that the difference between the length of the blue and the length of the black is this much? If I add the same amount to both, so I make the blue one or the bar on the left much longer by adding the orange. And I do the same to the black. Has the difference between the two changed? It's still this much. So in this so-called borrow and pay back method, there is no borrowing and there is no paying back going on. Okay? I've added 10 to the top number. If I just look at the top number as it is, it's 40 plus 10 plus 5. The number at the top changed from 45 to 55. It's bigger by 10 from when we started. So we increased the bigger number, and in order to make sure that we haven't changed the subtraction problem completely, we need to add the same amount to the bottom number, to the smaller number. So the smaller number has changed from 19 to 29, 10 plus 10 plus 9. So it's not borrowing 1 and paying back 1, it's adding 10 and adding 10 again, adding 10 to the bigger number and adding 10 to the smaller number. If you're teaching in a system where children or the students don't ask questions, then, you know, it works in terms of getting the students to do it that way and remembering the sort of almost a chant, borrow, pay back, borrow, pay back. But you're not really teaching them what's going on. Again, by discussing and doing the subtraction, showing each other collaboratively, they begin to see that, there isn't just the one way. And yeah, I think that's really important. So the language that we use when we're teaching needs to be aligned with what we're doing and what we're modeling. So if the language and the symbolic representation and the visual model all line up, then that helps to make meaning. But if the language doesn't match the symbolic representation and the symbolic representation doesn't match the visual representation, then that's going to cause a lot of confusion.